Hello, students. Another thing that we can use percents for is to talk about how far off something was in, like, when they estimate, when they guess something, or how much things changed. Because, like, if you say something went up by a cost of $1, it may not seem like a lot. If the cost of a new car is now $1 more, that's really no big deal at all. But if the cost of a 25-cent piece of candy is now $1 more and costs $1.25, that's a huge increase. So we talk about by what percent did it change. When you look at percent of change, first you have to know, like what I just talked about, how much did it actually change by? And then to see how big of a deal that is, you relate it to what that original amount was. So we're just going to put something over this, like a score on a paper, the amount of change over the original amount. And then just like on your score of your paper, you'll just divide it out, and then you'll be able to see your percent. You'll get a decimal, and you'll convert that to a percent. So let's see it in action here. Example 1 says, Mrs. Harkins was chilly one morning when it was only 58 degrees when she left her house at 6:30 in the morning to go to school, but then thought it was lovely outside when she left school in the afternoon and it was 84 degrees. What was the percent of change in the temperature that day? And whenever you're talking about the percent of change, we'd also like you to recognize if it's an increase or a decrease. And just like those vocab words suggest, increase means from the original, now the amount is higher. And decrease means from whatever it was originally, now the amount is lower. So first thing we're going to do is figure out our amount of change. And it changed from 58 degrees to 84 degrees. So I can subtract to figure out how much difference that is there. And I will see that that is a 26-degree difference. And then as the formula up above says, I will put that over the original amount. So I'll take that 26 degrees over whatever it was first. So first it was 58 degrees. And you are allowed to use your calculator. When you do that, you'll see it's about 0.448, just round it off there. So when I convert it to a percent to get my final answer, it's multiplying by 100. So after that 44 is an 8, so I'm going to say it is about a 45%, because that 8 tells me to round up. And it was an increase in the day because it went from 58 degrees to 84 degrees. Now I'm going to check if my answer makes sense. 50% means half, and half of 58 degrees would be 29 degrees. So if it went up 29 degrees, that would be a 50% increase. And I see here that it went up 26 degrees, just a little bit less than that. So my 45% makes sense. Example 2 says, Mrs. Ginnivan felt overwhelmed looking at the 45 boxes she had to pack in order to move from her apartment to her new house. She felt better at the end of the weekend after she had managed to get 21 boxes packed up and ready to go. So what was the percent of change in the number of boxes she still had left to pack from the beginning of the weekend to the end of the weekend? So at the start of the weekend, she had 45 boxes to pack. And then read carefully, because the next number isn't 21. It says she got 21 of her boxes packed up. So when I see that she did that, then that leaves 24 boxes left to pack. That's what we're comparing. We're not just comparing the two numbers that are in the problem. It says compare the amount of boxes she had to pack. So she went from 45 down to 24, and those are what we're going to compare. So I'm going to actually do my subtraction here to find the amount of change. And I would do the 45 minus 24 if I wanted, or I know that it's 21 boxes change because that's what the problem told me. And step 3 is when I put that amount of change always over the original amount that she had. So I'm going to put that 21 over the 45. And divide that on the calculator, you get 0.46 with that 6 repeating. So then when I make my final answer, I'll move that decimal twice to the left. It's 46 with another 6 afterwards, which is telling me to round up. So she had about a 47% decrease in the amount of boxes she had left after that weekend. We're going to do our you try a little bit differently this time. We're going to have you actually practice looking up data, because the question we have for you is, what was the percent of change in the number of wins that the Royals had from 2015 to 2016? So you're going to use your resources yourself. Look up how many wins they had during their 2015 season, record it here, and how many wins they had during their 2016 season, record it here. And be sure to give us your source right here. Cite your source of where you looked that up. Once you have your numbers, then you can come back and calculate your percent of change like we did in the examples. I want to make sure you actually looked up the data yourself, so I'm not going to give you the actual numbers. But to help you check if you did your work correctly, I will tell you that they had about a 15% decrease in the number of wins they won after they won the World Series in the 2015 season to their 2016 season. But you need to have filled out the amount of wins they had and the work that it takes to show this answer, the 15% decrease. Percent of error is very similar, except for it's not over an original because nothing is changing. It's just that somebody thinks one thing, but in reality, there's something else. And you're going to still put it over in a fraction like we did. So you're going to find the amount first, but the denominator, instead of saying original, it's going to say actual right there. And then when you divide, remember, you get a decimal, which is why you have to multiply by 100. So the other one should have said that as well to change it to a percent. So the example to show this, how similar it is example 3. Miss Puryear estimated that the Elf Jr. play would sell out if the crew sold 400 tickets. But Mrs. Davis corrected her and said there are actually 422 seats in the auditorium. So what was her percent of error? Well, one, to figure out the amount of the error she had, we would subtract them. So she was off by 22. And if it wasn't easy numbers, you would subtract. So here's a reminder about that, even though now you can just look at it and see that. And then you take that and you put it over the real amount, okay, the actual. That's what we're actually comparing it to. So she was off by 22, and it was out of 422. The most common mistake is students think it has to be out of the original. So what did she think first? But to figure out how far off she was, we have to compare it to reality, because, of course, we're not going to compare it to her own guess because she's right on at her own guess. When you divide this, you get about 0.0521. So then when we take that answer and we multiply it by 100 to turn into a percent, it's 5. The next number is a 2, so I don't have to round off. So she was off by about, squiggly equal sign member means about 5%. It's not an increase or a decrease because nothing was changing. All right, since that was so similar, we don't need another example of that. We're just going to have you make an estimate here. So what do you predict to be the heaviest weight of an NFL player ever to score a touchdown? So put the amount of pounds you think that person weighed right here. And then actually look that up on the internet. What was the heaviest person ever to score a touchdown? Record that right there. Tell me your source. And then you can figure out how far off you were. On this one, I can't help you know whether your answer was right or wrong because I don't know what your prediction was. So I can give you the fact the actual heaviest weight was 346 pounds. You're going to need to tell me a source where you can find that, and I want you to list which player it was so I know that you looked that up yourself. I will tell you in a sample one, like we'll pretend that my prediction was 310 pounds, and I'll show you the process you should have followed. But again, your answer will be different than mine based on what your prediction was. So 346 minus 310, I always take the larger or the greater value minus the lesser value. So then I was off by 336 pounds, and I'm going to put that over the real amount. So I'm going to put the 36 over the 346, not over my prediction of 310. When I divide that on my calculator, I get 0.104 approximately. So then when I convert that to a percent by multiplying by 100, I will say that I was off by about 10%. That's a pretty good prediction then. All right, those are your lesson for today. Make sure to highlight or record anything that you have questions about to talk with your teacher in class tomorrow.